In the years around 1580, in the city of Florence, Italy, in the home of Giovanni de' Bardi, Count of Vernio, a group of people came together to solve a common problem. Poets, philosophers, singers, astrologers, they called themselves the Florentine Camerata. Their mission? To reform modern music. What Vincenzo Galilei, member of the Camerata and father of Galileo, called corrupt and incomprehensible contemporary music, according to Wikipedia at one point in time. That music was polyphony, and it sounded like this. Very pretty. Polyphony has 4 or 5 melodies, all equally important, all intertwined and dancing with each other, and it's optimized for a feeling of holiness. But the Camerata dared to ask the revolutionary question, what if we could understand the words? In particular, they wanted to find a balance of words and music in order to maximally convey emotion and story, and emotions other than just holiness. So the Camerata set out to do this. What fascinates me about this group is how they remind me of a modern agile development team. See, they were a whole diverse set of skills. They had singers and composers, but also scientists and artists and philosophers. And everyone who was concerned with interesting things in the modern day, they all came together at the home of Giovanni de' Bardi and also Jacopo Corsi. So they had sponsorship. And really, it's more like a meetup than a team in the sense of they met in different places. But regularly, a common group of people came together to work on this. They had a common purpose to reform music, and they had some agreed upon methods. Now, musicologists are kind of back and forth on how serious they were, but the Camerata espoused going back to the ancient Greek ways of combining words and music, because back then they thought history moved in a circle rather than a progression or a spiral. So going back was also going forward. But it's not like they had recordings, right? Still, I think this lent legitimacy to their work, kind of like when I cite computer science papers from the 1970s. Okay, so I found the Camerata super interesting. And there's even more ways. When they came together and they met, Caccini, he was one of the musical stars, one of the singers. He said, I learned more from their learned discussions than from 30 years of descant. Now, descant, I had to look that one up. That means lecturing, so what you're getting now. Please use the rest of the conference for learned discussions. Also, the son of Giovanni de' Bardi, he remarked to his friends, he's like, dude, they get together for hours and hours, and nobody gambles and nobody drinks. Somehow they had fun, though. Now, they didn't just talk. They also experimented. They played music. So they practiced together, and they had code review. Now, I like the part where the censors who were nominated for the occasion to criticize the code, they were appointed. It wasn't just that asshole who hates you and takes it out on your code. That's important. Now, they didn't all get along. There was some rivalry. Bardi and Corsi, the sponsors, Bardi wanted to do more talking, and Corsi wanted to do more playing of music. But this worked out. And similarly, Perry and Caccini, Perry was like, it's about the words with some music. And Caccini's like, it's about the music with some words. But these things all balance. And in the end, they succeeded. The Florentine Camerata created the stile rappresentativo, which they invented opera, and they reformed music. It sounded more like this.
che rompe da verno pallido habitator la di cui mano.
Now, I still can't understand the words, but I don't speak Italian. And I hear that if I did speak Italian, it wouldn't help anyway, because this is ancient Italian. But back then, people did understand the words, and they got the feeling, and they got the story, and they really felt it. And this style of music, this radical innovation of one melody with a little bit of musical accompaniment, everything that seems obvious now wasn't always. This spread throughout Italy. The Camerata, they were corresponding with people in Rome and other cities, and so those people learned about this style and started using it, and then from there it spread into all of the Western world and ushered in the Baroque era. So they had a huge effect on the world. But that's not what interests me about the Florentine Camerata. That is not what caught my attention about this group. What I find interesting is what each of them did afterward. So here are some of the publications of members of the Camerata, and this is fewer than half of the Camerata members who have Wikipedia articles today. They did not expect that in 16th century Florence. And there's operas on here, yes, but there's also scientific and philosophical treatises in different fields. These people went on to do interesting things. I mean, now maybe it just happened that all of these great authors wound up in the same room together. But maybe there's a different kind of causality at play. So I went to research the Camerata, and I came upon this paper, Collective Problem Solving in the History of Music, by Dr. Ruth Katz, musicologist, and this was published in the Journal of the History of Ideas, which is an awesome name. And this paper talks about how the Camerata resembles the kind of invisible college that you see in science. And this is at least a recognized phenomenon now in science, but in science, we have these stories of discovery as an event that happens to a person. And we like to give Nobel Prizes to one or two people. But who worked in their lab? Who shared a faculty lounge with them? Who did they correspond with? In elementary school, I learned that Ben Franklin discovered electricity. But Ben Franklin, he was working with dozens of amateur electricians around the world and corresponding with them. And every experiment that someone else did wrong and published and told people about was one he didn't have to do. And then when Franklin, everybody had their own theory of electricity in this world, and when he came up with the one that worked the best, he had a whole network of people who were ready to understand what he was talking about and make use of it. So it's, in addition to who were you talking to, it's who criticized earlier versions of the theory, and then when you had the theory, who was able to spread it to the rest of the world. It doesn't work with just one person. So Dr. Katz talks about some features of invisible colleges. They have appropriate methods of research. So they agree upon what makes a valid experiment or what kind of process we're going to use in a team. Priority problems, that means fighting over who was first, so more on that later. And then the very important shared language that comes from shared work. So in domain-driven design, this would be the ubiquitous language. But every team has its own, some of them are colloquialisms, and some of them are carefully agreed upon definitions. We can talk to each other because we develop this shared language. One of my favorite camaradas in science is the Club of Honest Whigs. So now we're up to like 1770. And they met fortnightly in the London Coffee House to drink and dine and discuss politics, religion, and science, especially electricity. So Ben Franklin is in this group, and so is Joseph Priestley. So this story comes out of the book, The Invention of Air, which is about Joseph Priestley. Priestley is credited with the discovery of oxygen. He didn't do anything with it, but he did pass that knowledge on to Lavoisier, who created chemistry. Priestley, importantly, he also discovered the carbonated beverage, And that's something very useful to us today. And he passed that idea on to someone who made a lot of money from it. But my favorite thing that Priestley did was not recognized at the time. He did tons of experiments. And one of them was he puts a mouse in a jar, a sealed jar, and he sees how long it takes to die. And he puts a plant in a jar, and he sees how long that takes to die. And he's like weighing the mouse, he's weighing the plant, and various other insects and animals and were sacrificed in this process. But one day he put the mouse and the plant in the same jar, and they didn't die nearly as soon. This wasn't appreciated until like the 1920s, but he's the first known person to have observed the carbon dioxide oxygen life cycle. So that's pretty cool. Priestley loved this camerata. And this comes up over and over in science. You can find these all over the place. Of course, this also happens in art. And Dr. Katz talks about the salons in Paris, where you have people coming together, not just artists, but also critics and dealers and everyone who's a stakeholder in the art world. And they're talking about, in art, this common puzzle thing that they're solving together corresponds to an artistic style. So the Impressionists solved the problem of how do I paint not what is, but what I see. I got to go to Paris to give this talk, and I went up the hill at Montmartre, and I took this picture, which is like one of the salons where like Van Gogh hung out, and it was the Agile Bunny, except in French. And that was pretty cool. Also, I found this house with this plaque on it with a whole bunch of famous artists and printmakers and poets and stuff who all lived in this big house at the same time. Maybe not a coincidence. Van Gogh himself, this is something that he painted in the Netherlands. And there's a cabbage. I think that's a carrot, but it's not very orange. Meanwhile, his brother Theo is in Paris, and Theo is like, Vincent, you must come here. You have no idea what colors these people are using. So eventually, Vincent gets evicted from his house in the Netherlands, and so he does go to Paris, and he shows up at Theo's house, and sure enough, he learns about totally different ways to use color, and this is the Van Gogh we're used to looking at today. And Theo remarks, you have managed to create for us a circle of artists and friends. And indeed, a lot of these artists, they hung out together, they painted each other's portraits. I think Gauguin's the one that Van Gogh chopped his ear off for. And the paintings of Gauguin, Toulouse-Lautrec, show up 20 years later in the salon of Gertrude Stein. Gertrude Stein was an American, and she and her brother lived in Paris, and they had some money, so they fed a lot of artists. And she had the first modern art collection back when it was quite new. So she introduces Picasso and Matisse, and they have a bit of a rivalry, but that's fine, it's constructive. And in her atelier every Saturday, there was a big dinner, and lots of thinking people came through there. So you have painters interacting, but also mathematicians and poets and philosophers. And later, Picasso was one of the few artists who made money in his lifetime, so he's got his own salon. And he and Georges Braque invented Cubism. Cubism solves the puzzle of how do I paint not just one perspective, but all the perspectives, or many of them. And later, let's see, so in his salon, you've got photographers and writers and philosophers. And then later, one of the people who came through Picasso's salon was Alexandra Exter. She's from Kiev, so she goes back to Kiev and she takes what she's learned. And in her salon, these other Alexes that she went to high school with learn about this style. And Bogomazov, he makes this goat head painting, which is on my bedroom wall today. Ideas just get bigger as they move between people. And here's the thing, this totally happens in software. I gave this talk last December, and Kent Beck was in the audience, and he came up to me afterward, and he was like, I've totally seen this. One of my first camaradas was called the Hillside Group, and this is a group of people who came together to solve the puzzle of how do we make software that's code that's more comprehensible, and they had Christopher Alexander's architecture patterns book. And so they wanted to apply that to software. So they met several times over various years. And let's see, Grady Booch is known for object-oriented programming now. Ralph Johnson, he's one of the Gang of Four, so he went on to write the Patterns book. And many of these people came together later in the extreme programming movement and the Agile movement. But since then, Martin Fowler is the master of refactoring. He just put out a second edition. Ward Cunningham created the wiki. Michael Feathers works effectively with legacy code. These people went on to do different things after they came together to solve a single problem. And I've seen this in many other groups. So I go to lots of conferences, and I keep running into people who were at ThoughtWorks in London during this period. And this is when continuous integration and continuous delivery was created. Jez and Dave wrote the book on it. Now, they were at different customers, but they all worked for the same consultancy, so they were talking to each other, and they had to solve the problem of how do we deploy software in way less than 2 weeks without breaking everything. Now, since then, Jez has gone on with Nicole to write a bunch of books, more books about DevOps. But Dan North is known for behavior-driven design, among many other things. Nat Price has a book on unit testing. Sam Newman is the prophet of microservices. And I've seen another example like that, where I keep running into people from conferences who were in the same place as the original Spring Source team. So Spring was created to solve the problem of how do we write J2EE without poking our eyes out. And that was a hard problem to solve, but Rod created the original framework. Jürgen convinced him to open source it and build a company around it. And that company, which was one of the first commercially successful open source companies, I keep running into people at conferences. The other day at QCon London, I'm in the elevator, and I'm like, who's this Rob Harrop guy who's keynoting? And Rod and Christian are like, we know him. So Rod's my CEO now, but meanwhile, the founders of Elastic and TaskTop and venture capitalists, people left that group bigger than when they entered it. I think that's the lesson to take away from the Camerata. That is what caught my attention about them, is because the evidence is in music, in science, in art, in software. Great teams make great people. You want it to be the other way around. You want to hire a bunch of great developers and poof, get a great team. I've never seen that work. But I have seen this. Great teams make great people. And I've been part of some great teams, or I would not be up here today. Okay, so the next question is, why? Why does this happen? Because if we knew that, we could do it on purpose. Okay, so I have a model, a theory that kind of explains why. And it also answers some of my other burning questions about software development, so I want to share that with you today. It starts with Gregory Bateson. Okay, Gregory is the son of William Bateson. William Bateson was the first professor of genetics, because he coined the term. And so, like, you've got Gregor Mendel with his bean plants, who discovers or notices the quantization of genes, but he was working alone. He didn't have a camerata, so that just sat for 40 years until it was rediscovered, and William Bateson was one of the people who brought that out into the world. And then he names his son Gregory, after Gregor Mendel. And Gregory Bateson was an anthropologist, but he did a lot more than that, too. He also worked in psychiatry, where he and some others invented the concept of the double bind, and also started the field of family therapy, the radical idea that maybe you can't study the psychiatry of one person in isolation. We need to care about the relationships. He also studied communication in animals. So for a year, he had a dozen octopuses in his living room. That is so cool. One of his camaradas was the Macy Conferences on Cybernetics, and they met 9 or 10 times over 6 years or something, and this was a diverse group. So Margaret Mead is also an anthropologist, von Neumann and Wiener are mathematicians, of course von Neumann created some computers, Claude Shannon of information theory, Hutchinson was an ecologist, McCullough was a neurophysiologist, Lewin was a psychologist, So these people came together to study feedback loops and circular causality in biological and social systems. And out of this, you get the science of cybernetics, which we don't really talk about anymore. We talk about systems thinking. This idea that a system is more than the sum of its parts. You have to care about its relationships, and you have to care about its contexts. So one of Gregory's other contributions is his daughter, Nora. Nora Bateson is also an anthropologist, and she grew up steeped in this, right? Steeped in systems thinking, in deep context, in appreciation of relationships and interweaving. And she says, okay, this word systems is not cutting it anymore. It's too general, and it lets us think about something mechanical. So you might think of a system as a machine that if you just broke it down far enough and understood the parts and their relationships, that you'd be able to master it from the outside. In the 50s and 60s, now ecology is a field, and people finally appreciate the whole oxygen, carbon dioxide thing. And they have computers. So you've got hundreds of grad students spending thousands of hours in a prairie, and they cordon off square meters of prairie, and then they count all the blades of grass in a square meter, and they weigh all the bugs of each different species, and then they burn the bugs, and they weigh that, and then find out how much carbon is in each species of bug. Because they thought if they just got enough numbers into the computer and enough formulas that they could model the ecosystem, make predictions, master it. But it never worked. And that's because the species aren't the same from generation to generation. They're evolving. They're learning from each other and from their environments, and they're constantly changing and adapting. So you can't just act like a species is a species is a species going through time. Nora's like, we need a word for this, a word for systems like ecosystems and like every human team and company and family, where the parts don't stay the same. So she coined the term symathesy, from the Latin sim, together, and mathesy, learning. And a symathesy is a learning system made of learning parts, where the interesting bit is to look at the flows, not of carbon, but of mutual learning. So if we look at this, we know a system is not the sum of its parts. That would be an aggregate. System is also the product of their interactions, so that's traditional system. But a symathesy emphasizes that the parts are a product of past interactions. Now, this is definitely true of me. Everything I do in a team has two outputs, whatever side effects on the world, and the next version of me and of my team. But this is very powerful. There are no zero-sum games in a symathesy. We win together, or we all lose. And this starts to explain why great teams make great people. So if we look at a team, you've got some people and their environment. The leaf represents their environment. And we know it's more than the people, that our interactions matter. Thank you, Agile, our relationships. But it's also each of us are a product of those past interactions. So our team is definitely a symathesy. But what Nora Bateson doesn't have is experience on software teams. I think a software team is even more of a symathesy. And that's because our team is not only people. Okay, define a team as everyone required for me to be successful. And I define success as a developer as having an impact on some customers by operating useful software. Okay, to achieve that, I need some people. Some of them are even near me on the org chart. And I also need that software. The software that has to be running in production, and its servers and its database, I need all of that in motion and active in order to have an impact on customers. And it's always learning from me, because I change it, that's my job, I'm a developer, and I'm learning from it when it throws exceptions or adds log messages, changes data, but I can't do that directly. I need tools. I need my log aggregators, and I need my metrics, and I need database access. And I can't change it without tools, so I need my editors and my IDEs and my source control and my automated tests and my build pipelines. Now, I'm always learning through my tools. It's the only way I learn from my system. And I learn like, oh, a test failed. Well, that's informative. Let me go change that test. So my tools are learning from me. At the very least, I change tests. Hopefully, I can improve my deployment. And I can write queries, my log aggregator, and I can query the database. So my tools are learning from me as well. All of this is part of the Symathecy. It's a socio-technical system. And development teams are unique because we can change this. Lots of people use software, but our software learns from us. This starts to answer a couple questions for me. One is, why do I need to be able to bring my full self to work? Because to be part of a living system, I need to be alive in it. And another one is, why is this so hard? Because I've been a developer for 20 years, and it doesn't get easier. It just gets more and more interesting. And when I look at this web of relationships, and clearly I haven't drawn half of them on this diagram, I start to see, okay, yeah, maybe this really is hard. Now, it wasn't always that way. When I started as a new developer, I worked on one piece of the system. I was told how to change it. When I needed some data, I said, oh, how do we use the database? And they gave me a book on Oracle. Just kidding, I bought it myself. And I learned how to use it, and that was fine. It was simple, and I could totally do it, and I could go home at 5 and not care. But these days, if I want some data, I say, oh, which database shall we use? Or databases? And how shall we handle migrations? And how shall we do backups? And caching, et cetera, et cetera, et cetera. So my options are a lot wider, but there's a lot more to think about. My scope has increased, and it's no longer simple. And if you take this further, if you go to the realm of the senior developer, the architect, the principal engineer, whatever you want to call them, that person who is on the team, but thinking more broadly than just this team's software, who's familiar with the social and technical systems that are wider than just the one team. And these people have bonding social capital within the team and then bridging social capital outside the team, both within the company and without the company, because you never have all the knowledge that you need on your team. There's only so many people we can have and so much we can know. So you need to have contacts in the wider system and contacts outside the company too. So people you meet at this conference are important, bridging social capital, knowledge that you can draw on when you need it. And that is part of moving into the senior level of development, in my opinion. It's also very important that people on our team have influence in the wider organization. And that's because our team has to be able to change the wider organization. Every self-organizing system necessarily affects its environment. Ecosystems do this. Our teams have to do this. You can't just say, you team, go over there and self-organize and learn, but don't make me change anything. That's not how it works. It's symatheses all the way up. So that's important. There's one more thing I need to add to this diagram before I move on. There's one thing missing, and that is some emphasis on the difference between the social and the technical sides of this system. Because the people here can talk to each other, but they can't just look down and see what's going on in the software. Until Tron is a thing, they can't go into the software and kick it. They have to use tools to do that, and those tools lie on the line of representation. So the line of representation is that interface between the human and the digital worlds. Our command lines, so our keyboards, our mice, our buttons, and what we can see on the screen. So at a crudest level, you have SSH, but let's not. I don't want to be able to do anything to production. I want to be able to do the right things easily and correctly. So we make tools for that. And we make tools to better display what's going on in our software, generically like log aggregators and database queries, but then we create dashboards, and my favorite software all has good operator interfaces so that we can cross that line of representation with the mutual learning, because the whole point is to be able to learn from each other, and this makes it hard. And I start to realize how important my tools are. Another implication of this barrier of the line of representation is that when we're working with our software, specifically when we're deciding what to change or do next, we're not moving objects around on a table. We can't manipulate it directly. We have to manipulate our mental models. So everyone has a mental model of how the software works, but Woods' law says that for any system of sufficient complexity, and we're way past that, your mental model is necessarily incomplete and out of date. And everyone's mental model is incomplete and out of date in different ways. Now that's actually good because we don't want everybody to have identical mental models, because none of them can be complete. We have to have overlapping mental models, that shared language, so that we can communicate to each other. That's very important, and it takes a lot of work to maintain that. But we need different areas of expertise and up-to-dateness. And that's because the limitation in software teams is not what we can do. Okay, you can tell because we don't type all day, and most of what we type, we delete. Our limitation in changing software is how much we can know. And that's limited. In any one person, we can only know so much. Now, Cesar Hidalgo, he's a statistical physicist, and in his book, How Information Grows, he talks about the concept of a person byte, which is the maximum amount of knowledge that one human can cram into our heads over our lifetime. It doesn't matter how big that is. It doesn't matter whether yours is bigger than the person next to you. What matters is that it's finite, and it's way smaller than the complexity of the software systems we can build. So we need this balance. We need to have different mental models. But the accuracy of a mental model makes a huge difference in how much we can do. Because what matters is not just what is, it's what we see. Because that's how we make decisions, and can we do it safely? I started to appreciate just how hard it is to build up a good mental model when I read the book Vehicles by Valentino Breitenberg. This is a philosophy book out of like 1970 or so. And he talks about the law of downhill invention, uphill analysis. And this says that if you build a complex system from scratch, so you start with something simple, and then you add stuff, and then you add stuff, and you're building up your mental model at the same time, that is really easy compared to coming to an existing working complex system and figuring out how it works and building up a mental model from something that's already functioning. This explains why there are 1,000 JavaScript frameworks. Because it really is easier to build your own. To build just what you need, and then, add something else, and then, add something else, and it's obvious, I know how it works, why don't you? That really is, no, it's not less work, it's plenty of work. You get to do a lot of typing, you get to feel productive, but it's harder mentally to learn React. It's more productive in the long term, but it takes more effort, even though hundreds of people have spent thousands of hours answering questions on Stack Overflow and writing documentation and coming up with a really solid API. It's still harder to learn than anything you personally wrote. Mental models are extremely difficult, and they're extremely valuable. So then we wind up with situations like this one. Okay, so here you've got Purple Developer. Purple Developer has a really good mental model of the system that they work on. They probably wrote it. But maybe Purple's getting bored, wants to move on to something else, or there's just more work to do. So here come Blue and Green. They've been assigned to this project now, probably part-time. And they don't know how the internals work. They have an idea of what the system's for, and conceptually like that. But here they come, and they're trying to figure it out. Meanwhile, Purple is going through JIRA tickets and doing their job and making changes to the system. And it's quite easy for Purple to make changes to this system fast enough that Blue and Green will never get a grasp of it. They'll never be able to build up their mental model. There is no sufficiently smart engineer to build a mental model of a system that someone who already understands is changing really quickly. And this is terrible. But if purple is evaluated based on how many tickets they close, and if the team members are evaluated on their individual productivity, why would that change? Purple looks like a 10x engineer. Purple is over there getting things done, and he's like, these morons, they take a week to do anything, and then they screw it up. The learning is blocked here. And this gets into those priority problems. In science, this manifests as fighting over who is first, because one person is going to get naming rights. One person or lab group is going to get that Nobel Prize. This is Newton and Leibniz both inventing calculus and corresponding with each other in code because they want to share, but they don't want to share, because they don't want the other person to be first to publish. And this is totally not what I want to my teams, because ideas aren't like matter and energy. It's not you against me. This is not a zero-sum game. Ideas get bigger and bigger as we share them, and that's what I want in my teams. I want my team to grow, which this model gives me a definition of what it is for my team to grow. Because if my team were an aggregate, a sum of its parts, then I would grow it by adding more people. But that doesn't work, because there's a lot of overhead in maintaining that shared context and acquiring those mental models. More people does not make a better team. So we also know the relationships matter. Thank you, Agile. That was useful. So yes, we can be a better team by building better relationships with each other. But when you add in the software, and when you consider that this is a symathecy and what matters are the flows of mutual learning, then you can think about it even more differently. Because in this kind of system, in a symathecy, you don't measure the magnitude of the system by like quantity of size. When you measure the size of the economy, you don't measure geography. You don't measure how much money is in the economy. You measure flows. So if I buy a cup of coffee for $5, and the coffee shop pays their worker, and the worker pays their rent, and the landlord pays a plumber, that's $20 added to GDP right there. The economy is $20 bigger because it measures flows. In the prairie, they're measuring the carbon in each species because the magnitude of the ecosystem, the growth or shrinking of it, is measured in carbon flows. So every time one bug eats another bug, that's a transfer of carbon or nitrogen or phosphorus, whatever the limiting nutrient is, and that counts toward a bigger ecosystem. So the ecosystem can grow. I mean, yeah, it can expand geographically. That's also growth, adds more carbon. But it can also just grow like in complexity and richness with more species and more bugs eating bugs, eaten by birds, and eventually they die and go back to the bacteria. And all of those flows count toward the size of the ecosystem. So in our team, what we want to count are the flows of mutual learning between people, within the software, and across that line of representation. That's often a bottleneck, so it's especially high value to increase the learning there, to have better access to what's going on in our software, to be able to change it faster, and to have a nice, smooth delivery process so that you can put more learning into the code and get more out of it. And now these flows of mutual learning, most of them are very hard to measure, but they're not that hard to detect if you look for them. If you look for what did I learn today? What helped me today? Who helped me today? Who answered questions? If you look for flows of mutual learning and you value that in your team, then you'll let Purple fix this. Because the way for Purple to fix this problem is to take their hands off the keyboard, stop changing the system, only change it through the fingers of blue and green. So then you get pair programming or mob programming. And now Purple is saying, oh, change that. And blue and green can be like, well, how did you know to go here? Why did we change that? What about this over here? Oh, no, that's not even used anymore. Crap, I would have lost a week. And then Purple learns a lot of things that they thought were obvious. Because in this situation, Purple doesn't know how much they know. When you have this mental model, everything in the system seems obvious to you. But here's a trick. Whenever you go to use the word obviously, change it to, I can't explain it, but. Because there's something in your head that may not be in the other person's head. So purple learns what's not obvious, and purple also will learn various things from blue and green, and then the mental model will transfer, blue and green will get comfortable, and purple can go on and do something different. That's a real 10x developer right there. A real 10x developer increases the flows of mutual learning in the team. A real 10x developer is like Joe Armstrong, who values teaching more than his own ego. So it's ironic, or counterintuitive at least, that if you want to be a great developer, put the team first. Purple can sit there being fast on that one system for the rest of their life. That will not make them great. Teaching will. So there's a really good book, Obliquity, by John Kay. It's quite short. I recommend it. It talks about how you can't get profit by aiming for profit. That's not sustainable. You can't get to happiness by aiming for happiness. You'll just have fun for a little while. And this is another one of those oblique goals. If you want to be great, put the team first, and the team will keep making you great. And if you think that you can't hire great developers, there's just not enough. Maybe you need to relocate headquarters to San Francisco or London. It's not them. It's you. Great developers aren't born, and they're not trained. There's only so much you can get from YouTube or college. You can get some background knowledge, but you can't get the mental model that you need to do great work. Great developers are symathicized. So this is the point that I wanted to get to. This is what interested me about the Camerata, because I saw that in the Camerata. I saw how that group became great as individuals. And I also saw that in the various software teams, like the Spring team and the ThoughtWorks team. I saw that people, they all have great teams in their past. They all came out of learning from each other. But then I was reading this paper, and I got to a point that really surprised me, that was not what I suspected, and it led me to something even more interesting, and to a conclusion that's very audacious and exciting, and I want to share it with you. It starts with the environment that made the Camerata possible at all, with the surrounding culture. Sense of innovation in the air. Because this was Florence, the center of the Renaissance, at the height of the Renaissance. And there was all kinds of stuff going on. Oh, interesting aside about the word innovation. Back in Priestley's day, this was considered a negative word, and innovation was an idea that threatened the existing order and was therefore dangerous. But Priestley, and he did a lot of corresponding with Thomas Jefferson and John Adams and the other authors of the U.S. Constitution, and they all believed in politics, religion, and science that they could use rational thought to reason about consequences and come up with ideas, innovations, that made the world better. And Dr. Katz is using this in its positive sense. In Florence, there was innovation in the air, and the Camerata were like midwives to a century pregnant with ideological and social and cultural ideas, all of which contributed to opera. One of these was the idea of systematic testing and measurement. So the scientific method is just beginning to become a thing. And Vincenzo Galilei is the first known person to experiment with musical notes mathematically. So he did these systematic tests where he strung out a string and hung a weight from it until it made a C. Bing, 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 pretend that's a C. And then he tightened the string, like added more weight until bing, bing, bing. It's the next octave up. And then he also shortened the string to see how much shorter it needed to be to get bing, 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 to get the next octave up. And then he did the notes and chords and came up with all these ratios that were consistent and kind of brought the math into music. I'm sure that was useful to the Camerata somehow. And then in Priestley's day, in the Enlightenment, they had empiricism and the idea that you could come up with a theory, hypothesis, reason about the consequences that it would have if it was true, and then carry out experiments to test whether those consequences exist in the world. And that was helpful. And these days, we have new ways of thinking. Well, we have computers that can do more math for us. So we can simulate things and check things with a lot more data than we could before. We also have systems thinking. And we can look at systems in context. We can see not just one perspective, but all the perspectives. Not all laws are universal. The interesting ones are often local. And the interesting causalities don't work in a straight line. They're circular, like Gregory Bateson studied. So we have new ways of thinking. They had the printing press, so they could research ancient Rome. We have the internet for maximum dissemination of knowledge. But dissemination of knowledge is not enough because we're limited by that person byte. We're limited by how much knowledge can be in one person's head. So we need to be around. We need to be interacting with people who don't know the same things as us. We have some shared language, but we have different knowledge other than that. And that's the other thing that made the Camerata possible. Because the very existence of such salons like the Camerata was, of artists and singers and composers and philosophers being in the home of noblemen with the merchants and the clergy, this was new. And one of the reasons this happened was because art with a capital A became recognized as a thing. And this is the part that made me go, wait, what? There was a time before art was a thing? I'm like, I go to the art museum and I see stuff from 3,000 years ago. That was art, right? It's hideous, but we call it art. And yes, that is art. And we recognize that now. We recognize the beauty in it and we recognize the care that went into it. But back then, they didn't have that concept. In the Middle Ages, they had painters and sculptors and poets, but these were crafts. And they had guilds. And if you wanted to be a painter, you joined the painting guild. You got into the painting guild because your dad was in the painting guild, because it wasn't talent-based so much. And then you could. The positive was, if you hired somebody from the painting guild, you could be pretty darn sure that they could paint some facsimile of what you asked for. But then the painters, after a day's work, they'd go hang out with the other painters in the bar, or the goldsmiths, because that was the next guild over. So painting and goldsmithing, and then there's the blacksmiths, and you got competence. But during the Renaissance, they started to recognize individual excellence. Some painters started going outside the guild. And then you've got the merchants who can notice that these people who are specializing in landscapes or cupids on the ceiling or whatever, that are really good. And then you've got people with money who can compete to hire them, and so the prestige goes up. And then people noticed that there was a common thread between painting and sculpting and music composition. And they didn't have a word for it, but they understood that it couldn't be taught. And so it was prestigious. So then you get these academies where you can go and you can study painting along with sculpting, and you can hang out with various other artists and philosophers and historians. And then you get these cultured circles like the Camerata. I think these days we would call it creativity, but that back then they were just this magic essence. And so now you've got art as a prestige, and so you get these cultured circles, and you've got the singers and the composers in with the poets and the artists and the laymen, like the Camerata. The Renaissance was a time of decompartmentalization, which broke down the barriers that kept things in order and apart. Developers, testers, operations. You might eventually get what you ask for, but you're not going to get what you need from that arrangement. And the new style in the Renaissance emphasized expressive qualities, impact on the world, impact on people, over beauty of design and craftsmanship. it's not about code coverage. It's not about design patterns, because software is not a craft. Not anymore. It's bigger than that. Programming is a skill, and it's an essential skill. It's an extremely valuable skill. A painter has to know how to work a brush, what the canvas will do, how all the different colors of paint interact. That's super important. We need those skills. But Java, it's like acrylic paint. And Ruby is watercolor. And Bash is a song on a hurdy-gurdy. Don't put it in your orchestra. These are essential skills, but they are not the essence of what we do. I'm also not saying that software is an art. It's tempting, but art has an impact on the world. If I listen to a symphony or I look at a painting, I might be affected, and that might change what I do in the world. Software is way more direct than that. We change physics. Dude, where'd it go? If I pick up my phone and I touch that box in the right way, a car shows up and takes me where I want to go. That did not happen 5 years ago. That is new in the world. It's not only software, but it took software to make that happen. That's amazing. Code as a medium is unlike anything humans have been able to work with before. Okay? It is more malleable than hot metal. It's more moldable than plastic. You can almost design right into it. And the feedback loops. We don't have to wait 15 years for the bridge to fall down. We can run a test in seconds or push something out to the web and know within a couple weeks whether it affected people, whether it changed their behavior. That is learning like we've never been able to do before. It's not the same as engineering, although there's elements. It's not the same as architecture or any other respected profession of the past. It's something new. So software is not art, but you know what? If art wasn't always a thing, maybe software is the next thing after art that we don't have a name for yet. The closest I can come in words is that ongoing software development is the practice of semathesy. And that makes me a semathicist in the medium of code. I change the system from within it. And I love this. I love this slide, except for one thing. It has my name on it. Because ideas do not belong to one person. It takes a camerata and a community and a culture to make them real in the world. So we are all semathicists if we choose to think of ourselves that way. And I am so excited to be alive right now and in software. Because software is the next thing after art, and this is the next age after the Renaissance. We have new ways of thinking about the world and new ways of changing the world.
If we manage to get this right, they'll surrender by early night.
The world will never be the same.
Oh, Alexander.
That's my daughter Evelyn singing Hamilton, the modern opera. May our work have that kind of impact 400 years from now. Thank you.